In this video, we're going to learn about the sign test applied to matched pairs data. The sign test is an example of a non-parametric statistical procedure. Non-parametric statistical procedures don't rely on the data having a certain distribution, like normality. In a 1990 study, researchers used MRI to measure the volumes of various regions of the brain. Measurements were taken on 15 monozygotic twins, where one twin was affected by schizophrenia and the other wasn't affected by schizophrenia. The data we will consider are the volumes of the left hippocampus region in cubic centimeters. You can see the data in this table. The question is there evidence that the volume of the left hippocampus is different for people suffering from schizophrenia compared to people who are not? This is an example of matched pairs data. So for example, in the first pair of twins, one twin is unaffected by schizophrenia. The other twin is affected by schizophrenia. So the unaffected twin has volume 1.94 cubic centimeters. The affected twin has volume 1.27 cubic centimeters. Since they're the same except that one is unaffected by schizophrenia and the other is affected by schizophrenia, we can simply take the difference, 1.94 minus 1.27, and end up with 0.67. And instead of dealing with both measurements, we can just analyze the difference. We can use a paired t-test to analyze this data. In a paired t-test, each pair is treated as one observation, and the analysis is just carried out on the differences. In other words, we simply analyze the difference d here. The mean of the differences is 0.1987, the standard deviation of the differences is 0.2383, and there's 15 pairs of twins. So that mu d represent the mean for the population of differences in hippocampus volume. The null hypothesis that there's no difference is that mu d is equal to 0. The alternative is that there is a difference between the people affected with schizophrenia and the unaffected people, and so that's represented as mu d different than 0 or not equal to 0. The test statistic is the usual one-sample t statistic, and that turns out to be equal to 3.23. And we can calculate a p-value from a t distribution with 14 degrees of freedom. And from a t-table, we obtain that the p-value is less than 0.01. So there is evidence that there is a difference between left hippocampus volume in people affected with schizophrenia and people unaffected with schizophrenia. For a paired t-test to be appropriate, each pair of observations has to be independent of each other. So that means that each pair of twins has to be independent of each other, which seems to hold. The other assumption is that the differences, these differences are down here, follow a normal distribution. How can we check that? One way to check if the data is normally distributed, the data being the differences, is to look at a box plot of the differences. Well, this box plot looks right skewed. Here's the normal quantile plot. If the data were normally distributed, then these points would follow this straight line. But since there seems to be a systematic deviation from this straight line, this implies that the data are probably not normally distributed. The sign test for matched pairs allows us to analyze matched pairs data where the assumption of normality doesn't hold. Let P be the probability that the unaffected twin has a larger left hippocampus volume than the affected twin. The null hypothesis then becomes that P is equal to a half. The alternative hypothesis is that P is not equal to a half. In other words, the null hypothesis states that there's a 50-50 chance that the unaffected twin has a larger left hippocampus volume than the affected twin. It's interesting to note that p equal to half is the same as half the differences are positive and half the differences are negative. Or, that's the same as saying that the median difference is 0. The p-value for this test is equal to 0.001. In other words, there's evidence that there is a difference between the unaffected twin and the affected twin in terms of left hippocampus volume. In a paired t-test, we require that each pair of observations is independent of each other and that the differences follow normal distribution. But for the sign test, for matched pairs, we don't require that the differences follow a normal distribution. We only require that each pair of observations is independent of each other. The sign test for matched pairs is an example of a nonparametric test.